So basically this is our FPGA based TDR, and this is our FPGA Cyclone 4E, and this is ESP8266. FPGA is sending data to the ESP using UART protocol, and we have probed our LAN cable, which is of 290 centimeters. We have measured it using a measuring tape, and we are getting a distance of 256 centimeters, which is basically the location of this open circuit. So it's an error of around 34 centimeters, and this is our web server. The terminal is receiving the data from the ESP, and this is our web server, which is based on JavaScript and CSS. Also, we have integrated GEMINI API, in which we will enter the signal velocity with which the signal is traveling in our wire, and this is our cable edge, basically when we install the cable, and this is the visualization of where the fault has occurred. Now, to show that this is working extremely well, I will now add another cable to this transmission line, which is of 160 centimeters. So the data has now added up, and we can see where the open circuit has been shifted to. Thank you.
Everyone. So our project is an FPGA based time domain reflectometer TDR. So basically we are finding the hidden fault in cables through time domain signal analysis. So as we know that the modern communication and electrical system uses transmission cables, and detecting faults there such as open circuit, short circuit or impedance mismatching becomes really very difficult, time consuming as well as expensive. So TDR is basically a technique that identifies the cable faults by sending a short electric pulse through a transmission line and analyzing the reflected signal. Traditional TDR uses an external pulse which can disturb the system, and through using an FPGA, we don't need to send any test signal. That is, we can monitor the normal communication signal that is already present in the cable. Also, we can observe distortions caused by the reflection. We can measure the time difference between the original signal and the reflected signal. So, we are providing three innovative solutions. First is a pulse-based fault detection. So, we are using a TDR cyclone table, which uses a multi-phase time-to-digital converter to measure the signal reflection with high timing accuracy. Second, we are using real-time monitoring with IoT integration. So we are using an ESP8266 module to transmit the diagnostic data, which will come from the device itself, to a cloud-based dashboard for live monitoring and analysis. This will allow the user to remotely observe cable status and fault location in real time. Third, we are using an AI-assisted predictive maintenance. So here, we are using the GEMINI API to identify the patterns and predict potential cable failures. This will help to shift from reactive fault repair to proactive maintenance planning, and this makes the fault detection process easier to understand and analyze. So this is basically a transmitter signal, the reflector signal, and the combined signal data. This is the implementation of the high-speed counter with 4-phase clocking, which will allow us to have a more high accurate decision. So looking at the scalability of the project, so the current size of the market is estimated to be around $3 to $4 billion. And with the expansion of technologies such as 5G, broadband connectivity, and smart grids, the need for efficient cable testing and fault detection system is also increasing. Industries including telecommunications, power utilities, and manufacturing require reliable diagnostic tools to maintain the cable network, creating a strong opportunity for cost-effective TDR solutions. Our key competitive advantages are: first, we are providing a high-resolution fault detection. Second, we are using AI-driven predictive maintenance. Through using the GEMINI API, the system can detect patterns in cables' behavior and predict potential failures before they occur. Third, we are using a real-time IoT connectivity. With the help of ESP Dual, we are enabling live data transmission to a web dashboard. Fourth, it's cost-effective and very scalable design. So, For now, our product development plan is, now we have built a prototype. After 2 months, we are planning to optimize the system. After 4 months, we are planning to add more advanced features. And after 1 year, we are thinking of making into a scalable product. Thank you very much.